Good morning, my dear children. In previous session, you have learned about the difference of the sets, intersection of two sets, and Venn diagrams of difference of the sets and intersection of the sets, and some of the sums based on that. And in this session, we are going to learn some more definitions of the sets with examples and the sums from the exercises, that is 2.1 and 2.2, and what all the concepts you learn from these three, and to today's session you are going to learn the sums based on these concepts. Empty set, already you have learned the definition of the empty set. Means the set which doesn't contain any element in it is an empty set. You see here, there is a box with nothing, no element or nothing, no object is there in the box. So here the box is empty. So this is an empty set. Now, the another definition is that disjoint sets. What are disjoint sets? In the word itself, you can easily make it out that disjoint means that which are not joined. When there is no element in common both in sets A and B, such sets are called disjoint sets. You see the example here. Set A contains 2, 4, 6, 8 elements, and set B contains 1, 3, 5, and 7. Then A intersection B, if you see here, there is no element common in both the sets. So A intersection B is equal to 5. So such sets are called, here A and B sets are called as disjoint sets. You can see the Venn diagram here. Set universal set here, and in the universal set, set S which contains the elements 2, 4, 6, 8, and the second set T which contains the elements 1, 3, 5, 7. So no common, so both are not joined, separately drawn there. You see the other picture there. You have the two sets. One set is containing X, the other one is Y. One is green in color, the other one is pink in color. There is no common in both the colors, so they both are disjoint sets. Now, you see that some of the sums which are from explained given from the exercise 2.1. So, some more examples of the set builder form and the roster form. Already in the first session, you learned about this, how to convert set builder form to roster form, and as well as roster form to set builder form. So here I have again some more examples from the exercise, not examples. These all are from the exercise sums. So let us discuss about it. First question you see here, that it is that converting the given sets into set builder form. Set A is equal to 1, 4, 9, 16, 25, etc. 100. So we have to represent this in set builder form. So take it as set A is equal to x such that x is equal to n square, because all these elements are in the form of the square of numbers. So x is equal to n square, where n is less than or equal to 10. Means the n square means the n, the numbers, the natural numbers are from where? Are from 10. So that's why you must use it less than or equal to. So 1 square which is 1, 2 square which is 2, 3 square 9, 2 square which is 4, 3 square is 9, 4 square is 16, 5 square is 25, and so on. At last 10 square is equal to 100. That is why n lies between 1 to 11. So we can make it as n less than or equal to 10. Now the second question, C is equal to 2, 5, 10, 17. So you see here the solution. How we write this in a set builder form? Set C is equal to x such that x is equal to n square plus 1, where n is nothing but n is a natural number and n is less than or equal to 4. You give the values of n which is from 1 to 4 and check whether you're getting the set C elements or not. Let us just one example you see here. Suppose if n is equal to 1, then n square which is 1 square 1, 1 plus 1 which is 2, where we are getting the first element. Similarly, you can go for the remaining three elements also. Now the third one, f is equal to x such that x is a multiple of 4 between 17 and 61 which are divisible by 7. It means you have to choose here the two conditions where x is a multiple of 4 as well as and x which is divisible by x is divisible by 7. So f is equal to, you see here we have only two elements 28 and 56. These are the two elements between 17 and 61 which are multiples of 4 as well as divisible by 7. Now the second question is convert the given sets into rational form. At a is equal to x such that x is a natural number greater than 50 and smaller than 100. That means you must write all the numbers which are more than 50 and less than 100. That means 51, 52, 53, etc. 8, 98, 99. Now second question in that c is equal to x such that x is an integer and x is equal to 4. So we have to choose only the integer where the square of the integer must be equal to 4. So what are the integers? Minus 2 and plus 2. If you check there, minus 2 whole square, minus 2 to minus 2, what will you get? Plus 4. Similarly, 2 square is also 2 into 2, which is 4. So the closure form of the second one is minus 2 comma 2. Now the next one, third one is set d is equal to x is such that x is a two-digit natural number such that the sum of its digits is 8. So let us choose the two-digit numbers whose sum is equal to 8. Let us start with, we cannot write starting the 0, 8 because 0 plus 8 is equal to 8, but we cannot write 0, 8 is not a two-digit number. Let us start with 1, so 17, then with 2, 26, with 3, 35, 44, 53, 62, 71, and 80. You check that sum of the digits in the two-digit number in the set, the sum is equal to 8. Now, some more questions from exercise 2.2 as what you have learned from the previous sessions. Set A is equal to 1, 2, 3, 4 and set B is equal to 1, 2, 3, 5, 6. So find A intersection B. You all know that A intersection B is equal to 1, 2, 3, 4 intersection 1, 2, 3, 5, 6. The common is only 1, 2, 3, that is equal to A intersection B, which is equal to 1, 2, 3. Similarly, set B 1, 2, 3, 5, 6 and set A 1, 2, 3, 4. The intersection of both the common elements are 1, 2 and 3, so they both are equal. Now, set A is equal to 0, 2, 4. Then find A intersection 5 and A intersection A. So A intersection 5. A elements are 0, 2, 4. Intersection 5 means you know that there is no element in it. So empty set. So A intersection 5. What is the common element in both? There is no common element in both. So the answer is again 5. So A intersection 5 is equal to 5. Now A intersection A, that is 0 to 4 intersection 0 to 4. The common is what? 0 to 4. So A intersection A is equal to A. Now, third question. If A is equal to x such that x is a natural number, B is equal to x such that x is an even natural number, C is equal to x such that x is an odd number, D is equal to x such that x is a prime number, then you must find A intersection B, C intersection D, B intersection C, A minus C, D minus B, and A minus D. You see here, I have given only the example first one, set A contains, first you must write all these set builder forms into the roster forms and then you have to find that A the given, that is A intersection B, C intersection D, etc. as what all are given in the question. So first A set is what? X set X such that X is a natural number. So write all the natural numbers 1, 2, 3, 4, 5, etc. We cannot write all in the end of the natural numbers, so you can make it here the dots, that is etc. Now B set contains even natural numbers, that is 2, 4, 6, 8, 10, etc. Now C set is odd natural number, that is 1, 3, 5, 7, 9, etc. D is equal to the prime numbers. So 2, 3, 5, 7, 11, 13, etc. So A intersection B is what? 1, 2, 3, 4, 5, etc. And 2, 4, 6, 8, 10, etc. In both, we have common is 2, 4, 6, 8, 10, etc. That is nothing but set B. Now, C intersection D. 1, 3, 5, 7, 9, etc. intersection 2, 3, 5, 7, 11. Now, in this, the common elements are 3, 5, 7, 11, etc. You know that these all are the odd numbers as well as the prime numbers together in both the sets. When you extend it, you'll get still some more elements, but we have given only, I have given here only few elements in it. Now, B intersection C, that is 2, 4, 6, 8, 10, etc. They are even elements. And intersection 1, 3, 5, 7, 9, that is a odd number set. The common, there is no common in even number set and odd number set. So the answer is 5. So B intersection C is equal to 5. Now, A minus C, that is set A consists 1, 3, 4, 1, 2, 3, 4, 5, etc. elements minus 1, 3, 5, 7, 9, etc. elements. So from the natural number set, if you remove the all odd numbers, the leftover will be what? Even numbers. So that is 2, 4, 6, 8, 10, etc. So it which is equal to set B. Now D minus B. D set consists of all the prime numbers in natural numbers, that is 2, 3, 5, 7, 11, etc. minus B set is consisting of even numbers, that is 2, 4, 6, 8, and 10, etc. So the difference means you remove only 2 because the 2 is common in both the sets. So remove 2, then the leftover elements from set D are 3, 5, 7, 11, etc. So D minus B is 3, 5, 7, 11, etc. Now A minus D. A set is consisting of again all the natural numbers 1, 2, 3, 4, 5, etc. And D set is consisting of 2, 3, 5, 7, 11, etc. all prime numbers. So the difference means if you remove, you observe here say 2, 3, 5 and 11, these all are common in both the sets. So remove those elements from set A. The leftover in set A are 1, 4, 6, 8, 9, 10, etc. So in this way, you can find out when the roster form or the set builder form is given, to convert the given set builder form into the roster form and find out that whatever is given, that is A intersection B or A minus C or D minus A, anything you can find out. These, the last sum, which is very, very important for 4 mark question in your board exam, children. So you please note down all these sums in your notebook. You already kept one notebook. We in the month of February itself, we kept the new notebook. So my request is you copy down all these sums from 2.1 and 2.2 in your classwork, and you can do further sums. If your textbooks, you can do the further sums, and we are going to give some assignment questions also based on these exercise sums that you can complete. I hope you might have understood. I hope you might have understood all these concepts that what you have learned today. Only the disjoint sets is very, very important for the objective as well as the solving the sum as well as the Venn diagram also. And the sums from exercise 2.1 and 2.2. Thank you one and all. Thank you very much.